All right, good morning, my wonderful seventh graders. We are hitting our last lesson, last major lesson. We just finished up lesson 17 today, so that should put us at lessons 18 and 19 for tomorrow. We're going to combine these two lessons, and we're actually going to try to finish up with module 2, or excuse me, module 1. So that way we can go ahead and get our review and our test and go and see if we can't jump into module 3 just a little bit. So just be prepared. We got a lot to do, but I have confidence in us, and I think we should be able to manage this quite nicely. So lessons 18 and 19, let's go ahead and jump into it, and let's take a look at our PowerPoint to make sure that we're all on the same page here. Okay, so we just ended up all this stuff here. This was all from lesson 18 or lesson 17. So here we go. Module 1, lesson 18 and 19. Okay, so let's go through this together real quick. All right, Module 1, lesson 18 and 19. All right, so here's your warm-up question. All right, we're going to work on this tomorrow, so no worries there. All right, so our standard and objectives. Okay, so we're going to be working on 7GA1. We're going to solve problems involving scale drawings of geometric figures, including computing actual lengths and areas from a scale drawing and reproducing a scale drawing at a different scale. All right, so that's the standard. The objective here is that students will be able to solve problems involving scale drawings in order to compute actual lengths and areas from those scale drawings. So we're going to be working with some scale drawings. We're going to be working on computing actual lengths and areas from those scale drawings. So that's what our goal is today. So let's go ahead and jump in and let's take a look at and see what our first problem is going to be for the day. Here's our vocabulary. Hasn't changed. Enlargement, reduction. All right, here's some needed notes that you need to make sure you have from your last lesson. I think that's what happened is I ended up putting these in the wrong place. So I'll fix that. Now that I know where this is at, I can fix it. So here's your first problem, okay? So this is the problem we're going to model. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he is told that it will be approved if it fits on the empty lot that measures 25 feet by 75 feet on the school property. Okay, will the lot be big enough for the court he planned? Explain. So the scale drawing, it says 1 inch on the drawing corresponds to 15 feet of actual length. So we need to find out whether or not the scale drawing will fit on the 25 feet by 75 feet on the school property. Okay, this is actually quite easy. This is a quite simple problem. All right, it does not take too much effort. All right, we are going to be just fine here. All right, so let's go ahead and take a look and see exactly what we're getting into. Okay, and then we can find out whether or not it's going to fit. Okay, so let's find out here. Let's open this. Let's get out of this real quick, and then we're going to go into our actual work. Okay. All right. Here's our problem. Okay. Now, we need to find out if this fits in the proper lot. Now, the thing is, we need to, we've got two ways we can do this, and I want to make sure we use both, because both are going to be important to us, okay? So, the first thing I would do is I want to make sure that I write down that 1 inch of the scale drawing equals 15 feet in the real drawing, okay? So for every inch in the scale drawing, it represents 15 feet, okay? So 2 inches is the same as saying 1 inch plus 1 inch, right? So that means this would be 15 feet plus 15 feet. This is how it would work, okay? So we got 30 feet here, okay? That's how that would work, okay? Now, the proper way, like I said, we've told you this before, is that you're going to create a T-chart, okay? You're going to have your scale draw, or the original, okay, compared to the new. All right. The original states that there is 2 inches in measurement here, and that there is 1 2/3 measurement here. Okay. In order for us to get our new, which we need to know is going to be in feet, right? Well, 1 inch measures 15 feet. That's the scale. For every 15 feet is 1 inch on a scale drawing. So that's our factor. We're making an enlargement, so that means our scale factor has got to be greater than 1. So that's something that's important. We're doing an enlargement, Okay, when we can identify that we are working with an enlargement, we know our scale factor has got to be greater than 1. So in this case here, we're multiplying by 15. Multiplying by 15. Okay? We know 2 times 15 is going to be 30 feet. What's 1 2/3 times 15? Well, let's find out, shall we? Let's convert this to a mixed number real quick. Or not a mixed number, an improper fraction. 3 times 1 is 3, plus 2 is 5. So this is 5/3 times 15 over 1. All right, well, I know that 3 and 15 can be reduced by 3. So that's 1, and that's 5. Now I've got a problem I can multiply by. 5 times 5 is 25. 1 times 1 is 1. 25 over 1 is going to give me 25 feet. Okay? So I need to know if it's going to fit on the 25 feet by 75 feet of the school property. Okay? Well, we know the actual measurements here are going to be 25 feet by 30 feet. All right? So does it fit? Will it fit in the property? Yeah, it will. Okay? So because the actual measurements are only 25 by 30, we can state that yes, this lot is big enough for the court that Vincent's planned. The court will take up the entire width of the lot, but we still have plenty of room on the length. Okay? So we're fine. So yes, okay? Will the lot be big enough for the court he planned? Yes, it is. Okay? And I explained why. All right? The measurements here are less than the measurements here. So because these measurements are less than these measurements here, we know it'll fit. So we're all good. We're golden. Okay? So we know that this is going to fit on this basketball court. So by simply proving it, okay, in our T-chart, showing our original versus our new drawing and showing that our scale factor is going to be 15 because it's an enlargement, okay, makes it easy to do. All right? Now, let's take a look at our PowerPoint again and see where we're looking at. Okay? All right, so we continue on to the next one. Okay, this says guided instruction. But this is where we jump over to lesson 19. So I want to make sure that we understand oh, no, sorry. This is still in lesson 18. My apologies. This is still in lesson 18. Okay, so this is going to be the problem we're going to work on tomorrow in class. Okay, so be prepared. This is going to be a tomorrow question. So no bigs and no rush here, okay? All right. This is where lesson 19 starts, okay? This is where we're computing actual areas from scale drawings. This says guided instruction. However, I'm going to make this a model problem. I'm going to sit here and I'm going to show you how this works. And then we're going to do a couple more problems in class tomorrow to sit there and give you the guided instruction and the independent practice, okay? So let's go through these problems real quick. This is from lesson 19, okay? These are lesson 19 questions. All right, and I will show you. Oops, wrong thing. I want this one here. Okay, so lesson 19. You're like, Mr. Hale, what do you mean lesson 19? We just finished lesson 18. No, it's okay. We're going to work on this together. All right, so we got lesson 19 here, computing actual areas from a scale drawing. Okay, so here's your lesson 19. If you don't believe me, all right, lesson 19, grade 7, module 1. Okay, lesson 19, grade 7, module 1. So we are looking at computing actual areas from a scale drawing. So now we need to figure out some information here. So here's our actual picture. Here's our scale drawing. Okay, so we need to figure out a few things here. We need to figure out the scale factor. We need to figure out the actual area, the scale drawing area, and the value of the ratio of the scale drawings to the actual areas. Okay, so that's a lot of information to sit here and try to find. But we're going to do it. We're going to manage to do it, and we're going to do it just fine. Once my pencil here decides to move. There we go. All right, so what we need to do is we need to figure out a few little things here before we go too far. We need to first find out our scale factor. And remember, to find our scale factor, we just simply write y over x. Okay? Sorry guys, I'm just trying to figure out what's going on here because for some reason my app might need to be updated or something. I don't know. I'll have to double check that. So our scale factor is y over x. All right, there we go. Yeah, so give me a minute here, guys. I think I might end up having to pause, and we'll come back. All right, let's continue where we left off at. So we are looking at examples 1 through 3, exploring area relationships. Okay, so remember, your scale factor is yx. Okay, where our actual picture is x, our scale drawing is y. Okay. Forgive me, guys. It seems to be that even after the update, I'm still having a little bit of problems here. All right, let's see if it'll work without me going full screen here. All right, so we'll just see if I can make it just a little bit bigger. There we go. All right, so our scale factor is y over x. So in this case here, all we got to do is just take one of the corresponding sides and see what our scale factor is. So if I choose the 6 units, I got to choose the 3 units because this side corresponds to this side. Okay? So 6 over 3 gives me 2. So my scale factor is going to be 2. Okay? Now, the actual area, remember, now that we've got these things nicely set up in little circles, little cubes, we can count. But remember, area is simply length times width. Okay? So 4 times 3 is 12. But let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. Okay? So 12 units, all right, squared. And now the scale drawing. Remember, length times width. So 8 times 6, okay, is 48 units. Okay, so value of the ratio of the scale drawing area to the actual area. Okay, so now this is we're looking at a ratio. So the ratio of the scale drawing area, which is 48, to the scale drawing of the actual area, which was 12. 48 to 12 reduces to 4 to 1, or just 4. Okay, so that's interesting. The scale factor of the links is 2, but the scale factor of the areas is 4. I wonder why that is. Well, let's take a look at another example and see if we can't see if that pattern stays consistent, shall we? So here's example 2. So now we got the actual picture versus the scale picture. Oh, so now we're looking at a reduction, which means our scale factor is going to be less than 1. So we need to remember that. Our scale factor is going to be less than 1. So our actual picture is x, our scale drawing is y. Okay, so again, our scale factor is y over x. So we choose our corresponding sides. We're going to go with the 2 and the 6 this time. Okay, so 2 units over 6 units. All right, that simplifies to 1 over 3 because both 2 and 6 are divisible by 2. So our scale factor is 1/3. Okay, well, what's the actual area? Remember, area is your length times width. It's the inside of your picture, not the outside. So we're looking for the area of the inside. So you take the length, 6, times the width, which is 9. So the actual area is going to be 54 units squared. Now the scale drawing area. Okay, well, that's 2 times 3. That's 6 units squared. Okay, so the value of the ratio of the scale drawing, which was 6, to the actual area, which was 54. Okay, well, 6 to 54 reduces to 1 to 9, or as a fraction, 1/9. That's interesting. So again, the scale area is different than the scale factor. Why would those be different? What are we doing different here? Oh, that's right. Scale factors, if you remember, scale factors are just the ratio of corresponding sides. So we're just looking at length to length. Okay? But now the scale factor of area, we're looking at the ratio of the area to area. But in this situation, the area was when we took length times width and comparing it to length times width. So in order for us to find the square factor of our area, we'd have to take the scale factor of our lengths and multiply them together. You're like, Mr. Hill, what do you mean? Well, look, we did 3 times 2 here, right? And then we did 9 times 6 to find our areas. Well, if we did our scale factors, it'd be 3 to 9 and 2 to 6, which would be 1/3 to 1/3. So if we multiply 1/3 times 1/3, we get 1/9. Is that not right? 1/3 times 1/3, does it not equal 1/9? It does. So let's take a look at the example 1 we had. We had a scale factor of 2. Okay, 6 to 3, 8 to 4. Those scale factors are 2. So if we did 2 times 2, does that equal 4? It does. So if we take our scale factor and multiply it by itself, we get the scale factor of our areas. That's interesting. I guess we're going to have to spend a little bit more time discussing this tomorrow. But for now, that's the end, okay? I know it's a little longer than I promised, but we did cover 2 lessons instead of 1. So be prepared. We're going to have some practice work we got to do tomorrow, and we're going to have some other stuff we're going to work on. I'm probably going to have I'll explain it all to y'all tomorrow, okay? So just take notes, and I will see you in class tomorrow. All right, guys. Y'all have a good night. Bye.